So this just is like, it's like an uncommon sense, and I'm uncommon sense. It's like the opposite way around.
Yeah.
I literally just said so much.
Yeah, like you get it.
Yes.
All right, good morning, everyone.
Yeah.
Let me just go over the calendar again. We are finishing up on 4.1 today. We need to do the differential equations. Just finish up on notes there. I want to do a little bit more with Riemann sums. We haven't quite seen Riemann sums given to you with a table of values. So that's the handout that you just got. It's also in your packet, but I copied the table of values for every part. It makes it a little bit easier to make your markings without a lot of overlapping from previous parts. So we'll do that today. So I think we may not be able to get to the full quiz review until tomorrow. So we'll have tomorrow and Thursday to do our quiz review, and Friday is our quiz. I sent out a remind yesterday, just reminding you that I'll be checking homework tomorrow. Now, yesterday in my link, I also sent you a link to CalChat. So CalChat is just website that the book provides that has worked out solutions for every odd number problem. So all the problems that I assigned to you are odd number problems. So if you click on that link, you can just go to your section, a specific problem, and it'll give you the full worked out solution for the problems. Okay. So take advantage of that, especially if you're stuck on any of the problems from homework. So all the homework that I've assigned since last Tuesday, I'll check tomorrow at the beginning of class, and I'll send out a reminder this afternoon as well. Okay. I'll also send out a reminder about help sessions. So tomorrow I'll have a help session at 7:30, 3:40, and then Friday at 7:15. You can also join our Teams. So I will send out a Teams link. If you're at home, you can join in at those times if it's convenient for you. But if it's not, if you can't make it in person, I'll also have those recorded, and I'll put it on the website under tomorrow's date, so you can click on it and you can watch the video if you like. Okay. We need to finish up our notes from 4.1. So if you guys can go to page 8 in your 4.1 packet. So just to recap, we started a little bit talking about differential equations. Differential equations are simply equations that are at the derivative level. So anytime you see a y prime equals something, or f prime equals something, or f double prime equals something, those are considered differential equations. They're just basically derivative equations. When we talk about solving a differential equation, all that means is we're trying to get from the derivative level back up to the function level. So we're just involving the antiderivative in some form or another. So here are the steps for solving differential equations. We want to rewrite y prime as dy dx. Separate the variables. We want the y's on the left, the x's on the right, and then we just take the integral of both sides. So we started example 3. Let me recap the steps here. If we start with y prime equals 2, we rewrite y prime as dy over dx. Okay. We're going to multiply both sides by dx, move that dx over, and then we have 1 dy equals 2 dx. Okay. We take the antiderivative of both sides. Okay. 1 dy becomes y plus c, and then the 2 becomes 2x plus c. The reason that you know the 1 goes to y is because the dy indicates that we're dealing in terms of variable y. The dx tells us that we're dealing with in terms of variable x. We talked about how I can merge the c's together and just have c show up one time on the right side, and this is typically where the c goes. It usually goes as the end notation on the right side of the equation. Okay. Let's try example 4. Solve the general equation. So general equation just means that there's a plus c involved. Okay. And for example 5, when we move to order pair, then we're going to use the order pair to help us move from general to a specific equation or specific solution. Okay, so let's start off here. dy over dx equals x cubed. We can move that dx over to the right side, so that allows us to begin kind of separating the variables a bit. We're able to group the y's together and the x's together. There's not much to combine with the y's, it's just a simple dy. So this unit, yeah, 1 dy. There's not much that we're going to have to deal with the left side, but when we reach unit 5, we're going to have a lot more complexity on the left side. But right now, it's just going to be easy ones just with 1. Okay. Now we can just take the integral of both sides. Okay, we go through power rule from both sides. Y becomes y. Sorry, 1 becomes y. X cubed becomes what? What's power rule for x cubed? Yeah, x to the 4th over 4. We add 1 to the exponent. Whatever shows up in the exponent is going to be copied below. And then plus what? C. Yeah. So there we have it. That's our general equation. Our general equation has the plus c in it. Yep, you can pull that 4 out as 1/4. That's perfectly fine as well. Yep. That's right. That's right. As soon as you apply power rule, your integral and your dy or dx drops out, and you're just left with a plus c on the right side. Okay, good. Example 5. It says solve the specific differential equation. So when you see the word specific, just know that you have to get to the general first. Okay, we're going to get to the general first, and then we're going to update the general with a c value that is a number, and that will move us from general to specific. So general and specific just means, what do you do with that c value? Do you leave it alone, or do you try to get a number in place of that c? Okay, so let's start off y prime equals 3x minus 4. Let's make that y prime more specific looking. Dy over dx. That move that dx over to the right side. That can allow us to separate the variables. Now, when I say separate the variables, I mean y is on the left and x is on the right. But you're going to see this is going to be more relevant when we reach the second unit or the next unit. Sometimes you may have a value that feels like it could go on either side, right? That minus 4 feels like it could go on either the left side or the right side. But typically, anything that feels like it could go on either side, we want to go ahead and put it on the right side. Okay, the reason why is because we're trying to solve for y. When we're trying to solve for y, you're trying to leave the left side as minimal as possible. Okay, eventually the left side is going to be rid of most everything. So unless something has to go on the left side, you want to leave it on the right side. So basically, you're only going to pick whatever is necessary to show up on the left side on the left side. If something can be moved to the right side, the earlier you can move it, the cleaner things will be down the line. Okay, it's not going to really matter right now. Our equations are simple enough where it's not going to be something we have to be worried about. Okay, but we have our variables separated. Now we can take our antiderivative. 1 becomes y. And then the 3x minus 4, notice that these are actually 2 separate terms. They're both individual. Nothing, no parentheses, nothing is getting in the way. So we're just going to do power rule for each term separately. Okay, so 3x becomes 4 becomes 4x. Good. I want to make sure that we understand. I know the tendency is when you see a constant, you want to make it go to 0 because that's the derivative process, right? But this is the antiderivative. We're undoing the derivative process. Every variable is going to rise by 1 degree. So 4 becomes 4x. But now what's going to show up here? Plus c. Yeah. So it's going to have a constant after the integral process. Okay, so this is the general solution. Let me just want to indicate that. We could stop here if it was asking for the general solution. But it's asking for the specific solution. So what we're going to do is we're going to involve the order pair to help us get that C to a numeric value. So we're going to take the 4, replace the X, take the 10, replace the Y, and we're going to see if we can solve for our C value. Okay, so 16, 4 squared is 16, 16 over 2 is 8, 8 times 3 is 24. Okay, I'm just working my way down to a numeric value for C. 24 minus 16 is 8, and then 10 minus 8 is 2. Now that I have my C value found, I'm going to go back to my general equation, and all I'm going to do is I'm going to rewrite my general equation, but I'm just going to make a substitution. My C value is now going to be replaced with 2, and that will move me from general to a specific solution. Okay, any questions about how we move and from one form to the other? Yeah.
For the integral of 3x minus 4 dx, why isn't there dx?
Yes, we could make it 3x dx minus 4 dx, but really it's just one. We don't have to do integral of every term specifically. We can just think of it as 3x minus 4. Each of them are individual terms, but you could do this. You could say integral of 3 dx minus integral of 4 dx. But it's just understood that both are terms that are impacted by integral. So good. Any other questions? Okay. Now, the next page, we're going to continue practicing trying to get from derivative to a function level. But on the next page, we're going to do a little bit more because remember how first semester we're able to start at f of x, first derivative to get to f prime, second derivative to f double prime. So this semester, we have to be able to move up the chain at least twice, or at most twice as well. So next page, we're going to start at f double prime level. We're going to take the antiderivative. That's going to move us up to f prime. Take the antiderivative again. We'll move up to f of x. Okay, so we're going to have to go through this process twice within the same problem if we're starting at f double prime. Okay, so page 9. Okay, suppose f double prime equals 6x plus 4. We're given an order pair at the f prime level. We're given an order pair at the f of x level, and we're asked to find f of x. Okay, to help distinguish the constants of integration, each time we go through integral process, we're going to end up with a plus c, but just so that we're not mixing them up, we typically like to use a different variable for the second constant of integration. So I said plus k here, but you can also do, I use plus c sub 2 more often. But it doesn't matter, as long as you can have some sort of distinction between the c values and between the constants. You can use c or k, those are the most common ones. C sub 2 or k, those are the most common ones. Okay, so we got a little bit of a taste in terms of the differential equation notation. So here, we're just going to go use f double prime, and f of x. All right, so let's start off with f double prime. Okay, we're sitting at the second derivative level, and we're trying to eventually move up to the f of x level, integral process twice. Okay, I'm going to take the antiderivative, but I'm not going to do the process just yet. I just want to indicate what I'm about to do. I'm about to take the integral of 6x plus 4, Once I go through this process, the result of this process will leave me with something that's at the f prime level. Okay, so I'm just indicating what I'm about to do, but I haven't done it yet. Okay, all right, so now if we take the antiderivative, we can drop the integral, and that will be sitting at the f prime level. Okay. Okay, so let's go through power rule. 6x becomes plus 4x plus c. Okay, so we're sitting at the f prime level because we took the antiderivative once. This is our general equation of the f prime level. Do we have anything that we can use to update this f prime at this level? Can we solve for c at this point?
Yeah, use the word there.
Good. We don't want to use f of 1 equals 5 because why? Yeah, that's for f of x, right? This is not, these are not at the same level, right? But we do have something at the f prime level, so we can use this. Okay, so 0 goes in for x, 3 goes in for f prime, and that will allow us to isolate and solve for c and update our f prime from general to specific. Okay, let's do that. The 0 is going to be convenient. It's going to wipe out a lot of these terms here. 0 plus 0 plus c, c equals 3. So I'm going to use that and rewrite my f prime. Okay, so now we're halfway there. We got to go through the integral process again. So I'm just going to indicate what I'm about to do. To get to the f of x level, I have to take the integral of my expression. Okay, power rule. As soon as I apply power rule, my notations drop away, right? Okay, so 3x squared becomes 4x becomes 4x squared over 2. 3 becomes 3x. And then another plus c shows up. I'll use c sub 2. Okay, do we have something available that can resolve that c sub 2 for us? We have an order pair at the f of x level, so let's use that. 1 goes in for x, 5 goes in for y, or f of x, and we can solve for c. Okay. 1 plus 2 is 3, 3 plus 3 is 6. Subtract 6 from both sides, c sub 2 equals -1. So we'll now take that -1 and update our c sub 2 from the general equation. And once we do that, then we're able to, sorry, this one, right? We've already this cleaned up version here. So I'll rewrite my function, but I'm just going to replace my c sub 2 with -1, and that'll be my specific equation. there's my specific equation there. Okay, questions with number 6? Okay, we're going to follow a similar initial procedure for 7, except the order pair is going to kind of throw a little bit of a change in the way that we do things here. Look at number 7 here. G double prime is equal to 12x plus 6. G of 0 equals 4. G of 1 equals -2. What do you notice about the order pair that's different here? Yeah, there's no G prime. Okay, because there's no G prime, that means that when we get to G prime, we're not going to be able to initially get that C to be replaced, which means we have to hold on to that C a little bit longer in our process. Okay, so
like CX.
good. That's right. Yeah, so we'll treat C like we would a constant. So C will become CX. Good. So let's see if we can, let's arrive at that point and determine what we can do there. Okay, so our process will start at the same point. We want to indicate the fact that we are about to apply the antiderivative process. So we know that process will lead us up to G prime. Okay, so we're now going to do what we said we're going to do. Go through power rule. 12x power rule becomes 12x squared over 2. 6 becomes 6x, and then C shows up. Okay, questions with G prime. This is the general equation for G prime. Ideally, we would like to solve for C here, but we're stuck not being able to make much progress because we don't have anything at the G prime that can help us solve for C. Okay, so we'll hold on to that C and we'll solve for it later. Okay. So now that we're at the G prime level, we're going to move up to G of x. So I'm going to indicate what I'm about to do. To get the G of x, I need to take the integral of this expression. Okay, power rule for each term. 6x squared becomes, okay, good. 6x becomes, okay. All right, like what you said before, C becomes, that's right. Treat C like you would if it was like a 5 or a 6, pretend like it already had a number there, right? 5 would become 5x, so C would become CX. But this process will also produce its own what? Constant. So we'll have another plus K or plus C sub 2. So this is the constant produced from this process. This CX indicate that there was a constant produced from the previous process. Okay. It looks a little messy here, but we have 2 order pairs, and we can use those 2 order pairs to help us solve for 1C at a time. Now, look at the order pairs here. There's one that's going to be more useful to us at the beginning. Which one do you think would be the easier one? First one, okay. Why is G of 0 equals 4 better initially than the G of 1 equals -2? Yeah, the 0 is going to be really helpful, right? 0 is going to do its job of wiping out a lot of things for us. It's going to isolate that C sub 2 for us. And maybe you're thinking, wait, I need to solve for C before C sub 2. Okay, it really doesn't matter. We just want to choose, we just want to solve for which one is easier, right? Ultimately, we want to solve for both of them. Whichever one is easier, we'll go after that one. And once that C sub 2 is solved, then we can go back and use an order pair that can get that C. But if you have 2 missing variables, having that 0 is helpful. It's going to wipe out one of the variables because the X is going to do that job of taking that out. Okay, so we're going to plug in 0, 4 initially. Okay, so 4 goes in for the y, 0 goes in for the x, and we should get that c sub 2 solved for. Okay, the 0 wipes out everything. We can solve for c sub 2. C sub 2 equals 4. Okay, we're going to update our equation. We haven't gotten to the full result yet, but we're making progress. Okay. Okay, let's update our g of x equation, and we should be left with only one c left to do. Okay, so now this g of 1 equals -2 is going to come in handy. Okay, so -1 goes in for the y, 1 goes in for the x, and now we can cleanly get to that c. Sorry, yeah, -2 for the y, yeah, and 1 for the x. Okay. Okay, do some cleanup here. 2 plus 3 is 5. 5 plus 4 is 9. Subtract 2 from both sides. Sorry, subtract 9 from both sides. C equals -11. So once we have -11, then we can take that and update the C value from the previous update. And that will take us to our full specific solution.
So if we get one that doesn't give us G prime, will always give us a 0.
That's right. Yeah, yeah. It always give you a 0. If you're forced to have to do 2 C values at the same level, then one of them will be an order pair involving 0.
Can we get it the other way around where there's no regular G function and there's 2 G functions?
Yeah, it'll either be 1 G prime G of X or 2 order pairs at the G of X level. Okay, we'll do more practice of this, of these types of problems during quiz review, but just want to make sure that we understand this process this first time through. Yeah.
What if there wasn't an x equals 0 order pair?
Then we have to kind of go through systems of equations, a little bit messier. You won't see problems like that. I'll give you algebraically, I'll give you one that has a 0 in it. Yeah. Okay. I want to turn our attention now to the worksheet that you picked up. This worksheet is also in your packet, but I made it so that every problem had its own table. So because we have to make markings on the table of values, and it's just easier not having to overlap all those on the same table. Now, this is the handout up here. So do you have this?
I mean, I thought you just said like it was in our.
Oh, right. So yeah, so it's a page. Let me see, page. Oh, this is a 4.2, the first packet from last week. This is page. Page 17. So if you want to go to page 17 on the 4.2 packet, you can. Okay. But I also printed this out to make it easier to work with. Okay. So we haven't gone over problems like this where you're asked to do Riemann sums, which is just adding up rectangles, areas of rectangles in table form. Okay. But I do want to make sure that we understand that there's a distinction between this approximation, or the method of this approximation, versus the method where we learned initially when we started 4.2. Okay, so we're going to have to do both ways, but we don't want to be mixing the process and the steps for either of them. So just as a recap, remember how at the beginning or the middle of last week, I talked about how you can create the subinterval by going through the width formula, right? If I gave you interval with a graph and endpoints, you would take the A and B value, you would find the n value, and you would go through the width formula, b minus a over n, right? B minus a over n will do the job of separating each of your subintervals into equal widths. And once you have your width, then you start at the left endpoint. You keep adding your subinterval until you get to your next endpoint of each subinterval. Then you do width times height, and then you find the areas of those rectangles. Right. So that process we learned first, and we'll get back to that tomorrow. But today, your width is going to be predetermined. Okay, the table of values is going to determine what the width is. So the first thing that I want to make sure that we understand, and this is what kind of threw students off, was trying to force that b minus a over n into this problem, because technically there is an a and b value. There's an a of 0, there's a b of 20, there's an n of 3, but we're not gonna build our own width. The width is already here for us. So first thing you want to make sure you do is do not use this formula. Okay, this is not appropriate for these types of problems. It will not get you to what they're looking for. Okay, so do not use this formula. Only use this formula if it gives you the function and if it gives you the a and b value, n value, but no other information about the width. Okay, then you can build your width from scratch. Okay, but here we're not going to build our width from scratch. Okay, so this is a very specific way of going through this. I will say that the reason why I'm going through this is because on the AP exam, if it's a Riemann sums problems, chances are it's going to be in this form. It's going to they love to give table of values and ask you information from table of values. So part A says give middle approximation. So I meant to say middle rectangle approximation. Okay, and as a reminder, the area of a rectangle is just going to be width times height. And I'm going to show us how we're going to pull that information from the table of values. Okay. So first thing we do is understand that the width is going to come from your X row. Okay. And your height is going to come from the second row. Okay. But the way that we pull information is going to be different. Okay. So be very specific in the process that I want us to go through. Okay. Middle rectangles with 3 subintervals from 0 to 20. So we're going to have to extend, when everything's said and done, we're going to start at 0, we're going to end at 20. 3 subintervals. Now, the 3 subintervals doesn't mean that every width is going to be the same, but you will make sure that every subinterval sees and spans across the same number of order pairs. Okay, so but there's a very specific way I want you to do this here. Starting at 0, you're going to build your brackets, but the bracket, make sure that you start and end your bracket in the middle of order pairs. Do not start and end at the ends. It'll be hard to read. Okay, so we're going to make sure that we split them up into 3 subintervals. So let me just show you right now here. The first subinterval, we're going to go from 0 to 8. Eventually you're going to count, but right now I'm just going to show you. Okay. Now your second subinterval, you're going to pick up where you left off. So every subinterval is going to share the endpoint of the previous subinterval. Okay, so the second subinterval is going to start at 8. You're going to have to share that same order pair, and you're going to extend to 12. Third subinterval, start at the shared point, and then move to the end. Okay, now look, every subinterval spans 3 order pairs. Okay, you guys see that? Now the width may not be the same, but we are ensuring every subinterval is equal in the sense that they all see the same number of order pairs. Now, we're going to have to pull the width information from these intervals. The way you do that is you have to subtract and find the width of each subinterval. The middle number is not going to matter, okay? Not for the x's. Okay, so what's the width? What's 8 minus 0? 8. That's the width of your first rectangle. Okay. 12 minus 8, that's the width of your second rectangle. 20 minus 12, that's the width of your third rectangle. Okay? Now, the height is going to come from the second row, but there's a very specific way I want us to do this. You're just going to pull the number. You're not going to do any calculations, okay? So the 4 is the left height of the first rectangle. The 3 is the height of the right endpoint of the first rectangle. And 2 is the middle. You may be thinking to yourself, well, 2 is not the middle because 5 is not between 0 and 8. But middle is in quotes, okay? Middle is whatever they give you, okay? It could be at order pair 7. The x value could be 7. It could be a 1. As long as it's in between your two endpoints, that's good enough to be the middle. So you're just going to pull that 2 as the height. So your area of the first rectangle is just width times height, 8 times 2. You're told which height to use. Okay. Second rectangle, what's the height? Third rectangle, what's the height? 6. Okay. So we're just going to do width times height for our 3 separate rectangles. Okay. So here's our area approximation. I used squiggly mark to indicate that it's just an approximation. 8 times 2, 4 times 7, 8 times 6. Add those values together, and we get 92. Okay, so it's not hard, but it is very specific in the way that you pull information, right? If you happen to pull the information incorrectly, then all your answers are off. So it does require some practice, but then I feel like once you get it, you're gonna feel like it's pretty straightforward, pretty easy. Okay, any questions so far? All right, let's try part B. Okay. Same table of values. I just recopied it down so that we can have it for part B. Use right-handed rectangles to approximate area with 3 subintervals from 0 to 20. So same table of values, same subinterval, same interval. So our brackets will look the same as number 1. Okay. So middle to middle. Practice doing that. Width is still the same. Ignore all the middle x values they will not play a role for you. 8 minus 0 is 8. 12 minus 8 is 4. 20 minus 12 is 8. Okay, now we look to the second row. The second row is going to tell us the heights. Okay, we want to choose the right-handed rectangle here. So for the first subinterval, which y value do we want to choose? 3, right? The 4 is the left height, 2 is the middle height, 3 is the height on the right. Okay, for the second subinterval, what height do I want to choose? 3, yeah, but it's this 3, right? It's just so happens these are the same numbers, but it's this 3 here. And then for the third subinterval, what's our height? The 10. Width times height for the first rectangle, width times height for the second rectangle, width times height for the third rectangle. Okay, part C. Okay, use left-handed rectangles to approximate area from intervals from 0 to 9. What's different here? Okay, good. What else? Yeah, interval is different. So when we draw our brackets, we're not going to extend to 20, right? We're going to start at 0, but we're going to end at 9. Okay, how many order pairs is each bracket going to see then? 2. Okay, let's try that. 0 to 5. 5 to 8, 8 to 9. Every bracket spans across 2 order pairs, and we stop there, right? Because we're only going to go from 0 to 9. Okay, subtract your subintervals, subtract your x values to get your width. 5 minus 0 is 5. 8 minus 5 is 3. 9 minus 8 is 1. Okay, very specific. Some students are adding the values. We don't want to do that, right? Some students would say, oh, 0 plus 5 is 5, then they will do 5 plus 8 is 13. Right, you want to make sure that you're finding the distance. You're subtracting the x values to get the width. Okay, first subinterval was the left rectangle height. 4. Second subinterval, what's the height? Third rectangle, 3. Okay, make sure that you pair them up correctly here. Width times height, width times height, width times height. $20 plus 6 plus 3 is 29. That's the area approximation there. Okay, part D. Use trapezoids to approximate the area with 2 subintervals. You remember how we did trapezoid rule where we doubled up all the middle values? That's not going to happen here, okay? We're going to be finding the trapezoid area separately. We're not going to have to worry about spanning across, 5 or 6 different trapezoids and trying to merge them together. And also the widths are most likely different for each of these trapezoids. So as a reminder, the area formula for a trapezoid is width over 2, height 1 plus height 2. Every trapezoid, we're only going to pick off 2 heights, okay? We're not going to do multiple heights across just one trapezoid. All it requires for one trapezoid is height 1 and height 2. Okay, 2 subintervals from 0 to 20, okay? If you count, how many order pairs is each subinterval going to see? 4, okay? So start at the middle of the first order pair, go to the middle of the fourth, and then pick up where you left off. Make sure that you're always sharing when you build your next subinterval. Okay, we're going to create 2 separate trapezoid areas. Okay, what's the width of my first trapezoid? 9 minus 0 is 9. What's the width of my second trapezoid? 11. Okay. Okay, one area at a time. Width over 2, 9 over 2. Now we want a height 1 and height 2. If you had to guess, what heights are we going to be choosing for the first trapezoid? Good. So just what? 4 and 7. The middle ones are not going to play a role. I think some students in the past have messed things up because they would think, oh wait, I need to double all the middle y values, so they start doing 2 times 2, 2 times 3. We do that if it's spanning across multiple trapezoids and you're trying to merge them all together. We're just doing one trapezoid here. One trapezoid only requires 2 heights. These are not going to matter. Okay, just 4 and 7, just the endpoints. Okay, so we're taking care of the area of the first trapezoid, second trapezoid, width is 11. Okay, and what heights do I choose for the second trapezoid? 7 and 10. Okay, the middle ones does not play a role at all. Okay, does that make sense? Okay, just add that up to add that together in your calculator. You will get 143. Okay, a few minutes here. Can we practice with a few on the back page? Okay. Let's see if we can get through A and B. If not B, then at least A. Okay. Does anybody have any questions about this process? So it's not hard, but it's easy to make a mistake, especially if you're, mixing up between how to find the width and the height, or you're interpreting the area formula differently, and if you're drawing your brackets differently, right? It's there's a lot of things that could go wrong, even though this is doesn't look that hard. Okay, all right. Try part A for number 2. Middle rectangle approximation. 2 subintervals from 1 to 20. Okay. Are you good with the subintervals? How many order pairs for each subinterval? 5. Okay. 1 to 12, and then 12 to 20. Good. All right. What's the width of my first rectangle?
11.
Good. We just care about the endpoints. Okay. There's no need to do any type of fancy calculation here. You're just subtracting the endpoints there. 11. What's the width of my second rectangle? 8. Some students want to use midpoint formula. They try to overcomplicate things when they're trying to find the middle approximation. But we're just choosing between one of these 5 y values. So what y value do we want to choose for the first rectangle? 1. Okay. You don't have to do any fancy calculations. Some students went to the trouble of adding up the y values, finding the average between the two of them, and right, just pick out whatever's middle. Okay. Okay. How about the second subinterval? 4. Now, if I ask you for middle rectangles, your interval will always be an odd number of rectangles, or odd number of order pairs. You're never going to have to be left with 2 order pairs you got to find the average for. Okay, there's always going to be one that's right in the middle. Okay, so you see how there's 5 order pairs, right? The previous one had 3 order pairs. You're never going to be left with, oh wait, I got 2 order pairs in the middle. I got to find the average. It'll always just be 1 in the middle. Okay, okay, width times height. And the width times height, 8 times 4. Okay, 43. Okay, questions? So tomorrow, I want us to work through the rest of this in class, but I hate when I see students miss these types of problems because I feel like it's such an easy thing. So I hate it when I see students lose points because they didn't quite draw the rectangles right or something didn't go quite right. So tomorrow, as you try these problems, I'm going to walk around and confirm that you're comfortable with the width, the height, the interval, okay, and pulling your subintervals, okay? Tomorrow, help session, morning and afternoon. I'll be checking your homework, so at the beginning of class, so make sure you try to catch up with your homework if you're behind. And I'll send out a reminder this afternoon.
So on the C, how would you do 4 for 5 order pairs?
Oh, for C here. I'm only going from 1 to 12.
Oh.
So 2 subintervals.
Then if you start with the odd throw me off, then I'm guys going to 1.
Yeah. Okay.